I'm going to make sure it's muted because I know a lot of times when I go live on YouTube and TikTok, it mutes. I mean, I have to make sure it mutes so I don't get any feedback. Okie dokie, there we go. We're coming up. It's muted because I know. All right, so let me go ahead and switch the screen so you all can see that we are now live right here. Okay, and let me go ahead and get to the density notes. All right, so there we are. We are here now. So allow me to reintroduce myself. My name is Professor TK the Chemist. And for those of you all that are not familiar with me, I go live Monday through Thursday, 12:15 p.m. Eastern Standard Time, as well as in the evening time, Monday, Tuesday, Wednesday, Thursday at 7 p.m. Eastern Standard Time. So we weren't live yesterday because we were, it was Memorial Day. And if any of you all have military family members, that was a time to take the time to pause for them and to make, that acknowledgement. And so today, what we're doing is we're going to actually get into our lessons and we're going to actually talk a little bit about this whole process of density and what it means. I know many of you all have seen experiments online, so you can kind of follow along with that too. But what I want you guys to think about is, what does density mean? Now, many of you all may be familiar with the fact that things can either sink or float in different substances, depending on what you're working with, whether it's a solid, liquid, or gas. And you've seen oil and vinegar, like if I had some Italian dressing, that the two don't mix. Oil and vinegar do not mix. And so they tend to separate where your oil will go where. Your oil tends to float and your vinegar will go to the very bottom, or your water will go to the very bottom, because the two don't gel. Now, if you think about density and how this relates to chemistry, though, this is what I've got right here, okay? So last week when we were together, we discussed how to do density in terms of calculations, like with the metric system, because that's what you're going to get into today. Okay, we're going to actually target a lot of the things that we discussed last week. That's going to also go on today. So as you can see, let me find my pen that I write with. Okay, so that we can go ahead and get into this lesson today. And if you all have any questions, by all means, let me know. Okay, let me know. And what I'm going to do now is kind of go through a couple of things. So when you think about density and how it's used, there are different units that are associated with density. Okay, different units that are associated with density. Things like grams, kilograms, centigrams, liters, milliliters, cubic centimeters, okay? The formula for density, though, is D equals mass over volume. D equals mass over volume. Now, what you also need to keep in mind is that when you look at this formula, you can actually get two other formulas out of this. So you can also get volume is equal to mass over density, and then mass is equal to density times volume. Okay, so those are your three main formulas that you can use to identify density-based problems. Okay, these are your three main formulas right here. Now, I'm going to be very specific, though, when I give you the formulas, or rather the units for density when it comes to mass. So when you're looking at mass, you can say a gram, you can say a kilogram, okay, you can say a centigram, you can say a decagram, or decigram. So anything that's gram related, or even pounds, but you typically see grams associated with your density-based problems. Volume could be anything like milliliter, a liter, a centiliter. It could be cubic centimeters, okay? It could also be cc's. Like if you're working in the healthcare industry, you would have seen this before as well, okay? cc's is equal to cubic centimeters. Like they're used interchangeably, and because they pretty much mean the same thing, okay? Depending on how you want to abbreviate it. Now, what you have to remember though is when you are talking about density, you want to combine these two units. And so if I were to give you a unit for density, it's the mass unit divided by the volume unit, okay? So I could have a gram per milliliter. I could also have, let's say, a decigram per milliliter. I could have a kilogram per liter. So in other words, it's some mass unit per volume unit, okay? It doesn't matter what the mass unit is, and it doesn't matter what the volume units are, as long as you are knowing that you're dividing the two. Now, the reason why I bring this up is because when we do these density problems, like the ones that you see coming up right here, you're going to have to know which units to cancel out, which ones to keep. But until we get to that part, let me go ahead and zoom in a little so you all can see how this all works, okay? So whenever I go over this problem sets with my students, I always have them look at the volume, okay? Or look at the units rather, and determine. So in this case, you're going to determine what your units are for the particular formula. So if I'm trying to solve, let me zoom in so y'all can see this, okay? So if I'm trying to solve a volume problem, we're only looking at volume. Remember, the formula for volume is mass per density. So if your unit that they're giving you is a kilogram for the mass, and on the very bottom, the unit that you're giving you for density is kilograms per milliliters, well, you know what's going to cancel out? Your kilograms, okay? And so you're left with milliliters in this particular case. So if you're looking for volume, you're going to have a mass unit on the top and a density unit on the very bottom, but your things that are the same, the units that are the same, they're going to cancel out, and you're left with milliliters. Take a look at this next example. You've got grams on top, but grams per liter on the very bottom. Again, your grams are going to cancel out, and so you're left with a liter. And on this last example right here, notice that you have milligrams on top, but on the very bottom, grams per liter. Well, we taught you guys last week that whenever it comes to canceling things out, particularly units, you've got to make sure that they are the same. So you have to convert your milligrams to grams first in order to be able to cancel out your gram unit, okay? So you cannot you cannot get rid of a milligram with a gram because the units aren't the same. So the only way that you can do that is by converting your milligrams to a gram, and then you've got grams per liter. So your grams are canceling out. All right. Suppose we were asking you guys to now look for mass, okay? For mass. So in this particular case, if I'm asking you to look for mass formula, again, is density times volume. So here are your units. It's kilograms per milliliter times milliliters. And if that looks confusing, I'll write it like this: kilograms per milliliter times milliliters. Well, in this case, your milliliters are going to cancel out, so you're still left with kilograms, okay? And the next one for mass, again, you know the formula is density times volume. You're still going to say, let me make sure that my units are the same. I've got kilograms per cc's times milliliters. Well, if you remember what I just said a moment ago, cc's is the same thing as a milliliter. So guess what? You could technically cancel those two out together because they are the same. And so you're left with kilograms. And in this last example right here, again, we know that mass is equal to density times volume. I'm just repeating the formula over and over and over so that you guys can hear it and become familiar with it. You know that because you have a grams per liter for your density unit, but for your volume unit, you have milliliters, you cannot cancel milliliters with a liter. Instead, you must convert milliliters to liters first in order to be able to get rid of that liter that's on the bottom for your density value, okay? So in order to do that, If you convert your milliliters to liters, you never change your density unit because that's going to be what it is, but you can change your volume unit. And once you change that, you'll end up canceling out your liters and you'll still end up with finding your units for grams. Now, the reason why this is important is because now we're going to get into some word problems or practice problems rather, so that you guys are able to go through and know how to solve these problems, okay? So what I'm going to do, I'm going to actually go through one example at a time, okay? So like for instance, in letter A up here, we're wanting you to calculate the density given the mass and the volume. Now, here's what we're going to do in this box over here. We're going to put what the formula is, which is D is equal to mass over volume. So that way you'll know to refer to that formula every time you see a density problem, okay? I'll just do letter A for this problem. And if we have time, we'll go to letter B. So for letter A, because I know that density is equal to mass over volume, they told us that the mass is 12.2 grams and my volume is 3.43 milliliters. So what are you going to do? You're going to divide those two numbers. Something else you need to remember too is that your significant digits rules plays a role. You've got 12.2, which is 3 significant digits. You've got 3.43, which is also 3 significant digits. So 12.2 divided by 3.43 gives us 3.556. Now, this is on my calculator, okay? 3.556. But you have to know that we only need 3 of those, okay? Chris, I have plenty of those on my on my YouTube channel and on TikTok, and they're actually organized by the category. So you can actually go and find those on the video. Yeah. So now what you're going to do is, because I only need 3 of these numbers right here, you're welcome. Because I only need 3 of those, I know that 6 tells that 5 next door to it to round up. So this answer becomes 3.56 grams per milliliter, okay? 3.56 grams per milliliter. Whoops. Okay. Again, that's for letter A. That's for letter A. Now, for letter B, it says calculate the volume. Again, the formula for volume is equal to mass over density, okay? Mass over density. So therefore, what we're going to do, we're going to go over here and we're going to do letter A as well, okay? So for letter A, again, mass over density, you've got 14.45 grams divided by 0.982 grams per milliliter. Now, what you're going to do, you're going to cancel out your grams, grams goes away. And what you're going to now do is insert your values, okay? Remember, on the top, we have 4 significant digits. On the very bottom, we have 3. So I'm going to say 14.45 divided by 0.982, and that gives us 14.71. But remember, I only need 3 of those numbers. So therefore, I'm going to get rid of the extra 1 on the end, and the answer is just simply going to become 14.7 milliliters. Okay, 14.7, because we only needed 3 significant digits. All right. So now in the last category right here, we've got mass. They want you to calculate the mass. So again, the formula that we're going to put over here in this box is the formula for mass, which is equal to density times volume. Okay. So therefore, in this case, again, we're doing letter A. Okay, letter A. So we're going to say that mass is equal to density times volume. So the density in this particular problem is 3.91 grams per milliliter times, and look at your volume there. Your volume is 14.45. So milliliters. So I'm going to go ahead and cancel out your mLs, okay? And so now you're going to plug that into your calculator, all right? And you're going to say 3.91, whoops, there we go, times 14.45, and that gives us 56.4995. Okay, again, I'm going to write most of those numbers out, but you know we only need 3 of those significant digits. So because we only need 3 of those numbers right here, what we're going to end up with is the 9 is going to tell this 4 to round up. So you end up with 56.5 grams. Okay, 56.5 grams. Any questions from anybody regarding what we just went over with these types of problems? Okay, so let me zoom out so that you guys can see that. Okay, any questions? Okay. So now we're going to keep pushing them, okay? We're going to keep pushing. And so, and as you guys can see, these are the answer keys right here. So for those of you all that like to, do practice problems, whenever I do my study guides, I always provide the answer key so students are able to go in and make sure that they got what they need in terms of the solution. So let's do a word problem, okay? Let's do a word problem. So let me go ahead and screen share a different set of problems right here. And I got to make sure that you guys can't see the answers just yet, okay? So that we're able to, yeah, we don't want y'all seeing the answers. At least not yet, okay? So let me highlight some of this. We're going to do just one of each problem, so that way you guys will at least know what to do. Okay. And that way you guys will know what's going on, okay? So let me go ahead and screen share a different one. Okay, there we go. All right, so now let me go ahead and delete everything that you guys see here in terms of the answers, because I can solve the problems and I don't want you all to see the solutions just yet. So I'm actually deleting the answers off so we can actually work the problems out together. Okay. All right. Okay, so here we go. All right, so right here, this first problem, you're solving for density, okay? You're solving for density. And how do we know that? Well, let's read it so we can see. It says a nurse in an inner city clinic, or it could be in an urban community, or it could be in a community period, okay? Needs to administer a dose of a liquid medication. The medication has a mass of 12 grams and occupies a volume of 10 milliliters. Calculate the density of the medication to ensure it matches the prescribed density of 1.2 grams per milliliter. All right, so what you need to do first, okay, is we need to first figure out what did they give us in the problem. They told us that the mass of this medication was 12 grams. They told us that the volume was 10 milliliters. They want you to calculate the density of the medication to ensure that it matches the prescribed density of 1.2 grams per milliliter. Now, why is that important? Is because sometimes you could be administered a prescription that may not match the correct illness, okay? And so in this particular case, we want to make sure that whatever the doctor is prescribing, that if we go to a chart, that it matches accordingly. So in this case, D equals M over V. We know that's the formula. The mass was 12 grams and the volume was 10 milliliters. Now, this is quite simple, right? You're not dealing with any decimals at all, but we got to make sure that our answer is in one significant digit. And here's why. 10 on the bottom is one significant digit. 12 up top is two significant digits. So now when I say 12 divided by 10, I get 1.2, yes. Now, this answer is technically close enough, and it matches the prescribed density that they gave us in the formula or in the problem, 1.2 grams per milliliter. But let me just put a warning here for you. If this was a calculated problem that you were doing on, let's say, mastering chemistry, like we assign mastering chemistry for our school. Some of you all may be on a different learning system where the computer actually grades the work for you, and they'll tell you to put the answer in the correct number of significant digits. So if you put 1.2 as the answer choice, they will mark it wrong. And I know it's so confusing to think of it that way, but it's like you've got to get used to writing answers in the correct number of significant digits, particularly for chemistry. Now, when you get to physics and other classes like that, your professors may say, just round the number off to, 3 significant digits, for instance, okay? So that's why I'm putting these answers in the correct format so that you can be accustomed to seeing it that way. Let's move on to the next problem. In this case, you're solving for mass. Okay, so here we go. It says, Dr. Jackson, an African-American oncologist, needs to determine the mass of a chemotherapy drug required for a patient. The drug has a density of 1.3 grams per milliliters, and the patient needs a 50 milliliter dose. Calculate the mass of the chemotherapy drug. So let's look at what we do know. Let's look at what we do have, okay, in the problem. So they told us that the drug has a density of 1.3 grams per milliliter. The volume is 50 milliliters. What we need to calculate is the mass. So again, mass is equal to density times volume. So in this case, I know that I'm going to plug in the density that they gave us was 1.3 grams per milliliter times the volume, which is 50 milliliters. Your mLs are going to cancel out, and you're going to plug in 1.3 times 50, and we get 65 milliliters. Again, if your teachers ask you to put this in the correct number of significant digits, then your answer would actually be 70 milliliters because you would only need one significant digit. Why? Because this 50 here is only one sig fig, but over here in the number of 1.3, you have two. So if your teacher says, put this answer in the correct number of significant digits, you would round this to 70 milliliters to give you one significant digit. Okay, let's look at the next one. Solving for volume, solving for volume. A healthcare technician, let me delete this right here, okay? A healthcare technician needs to prepare a saline solution for a patient suffering from dehydration. The solution has a density of 1.05 grams per milliliter, and the technician has 210 grams of saline. Calculate the volume of the saline solution. So what are you going to do? You're going to say volume is equal to mass divided by density. So again, your mass is equal to what? The 210 grams. And on the very bottom, your density is equal to what? 1.05 grams per milliliter. Again, you know that your grams are going to cancel out because they are the same. And because you're looking for milliliters or your volume, that's why the milliliters are left over. So what you're going to do, you're going to say 210 divided by 1.05, and that gives us 200. 200 even to be exact. milliliters. Again, if your teacher said, put this in the correct number of significant digits, now in this case, because like the number that we got on the calculator was 200, right? But in order to put this in the correct Sig Figs, you would have to put it in scientific notation. And I know that's like, well, what for? Well, that's only if they're requiring you to put this in the correct number of significant digits, because you cannot put 200, like you can't put a decimal like at the end of that number, because then that's going to give you 3 significant digits. So if I move my decimal 2 places over to the left, that gives me 2.0, which is your 2 significant digits, but your exponent will be times 10 to the second power milliliters. That's the way you would put it in 2 significant digits, FYI. All right, any questions so far from anyone? Okay, let's take a look at this last problem right here. Okay. This is forensic pathology. Even forensic scientists and pathologists have to do the same thing when it comes to calculating density. Do you know during autopsy times, they actually take all the organs out, and they actually weigh them to make sure that whatever the person may have, died from, they're able to track that by looking at the density of the kidneys, the heart, the stomach, the lungs, and all of that. And they're able to match up certain things to determine if there was a certain medication that was given and so forth. So during an autopsy, a forensic pathologist named Dr. Ayanna Carter examines a sample of bodily fluid found in the victim's stomach. The fluid has a mass of 30 grams and a volume that occupies 27 milliliters. Calculate its density. So what are you going to do? You're going to say, all right, D equals M over V. So your mass is equal to 30 grams and your volume is equal to 27 milliliters. So what you're going to do is say, all right, 30 divided by 27, and you get 1.11111 continuous ones. So in this case, 1.11 grams per milliliter is your answer. But again, if your teachers were being very specific, you could just say 1 because of the, 1 significant digit in 30. All right. So these are just some examples of how you're able to apply density. And if you have further questions, you can always look on my page and you can get several of these different example problems as it relates to this particular topic here. Okay. If you guys don't have any further questions, I am going to go ahead and close out today, and I will be back on at 7 p.m. for my students who are getting help in chemistry during the evening time. You guys have a good one.